Hello. In this video, I'm going to be going through the CodeCheck Python exercises for the assignment loop algorithms. Let me go full screen now. When computing an average, you should ensure that there is at least one input, otherwise a division by zero error will occur. Rearrange the following lines to produce such a loop. So apparently we're supposed to be computing an average, and they're mentioning that we need to make sure there's one input so the user can't just quit immediately and give no inputs, otherwise our program is going to try to divide by zero, which is not valid. So the first thing that we need to do when calculating an average is initialize the two components, the total and the count, and then at the end we need to divide the total by the count. That's how an average is calculated. So I'm going to click Start. And then I know the last thing where we're going is to make the average be the total divided by the count. Then I know the first thing I need to do is initialize the total and the count. So the first thing would be the count is 1. We have one value, and the total is going to need to be some initial first value that they said we need to take in. So we don't have that value. There's this variable of, or wait, this is the wrong line here. We need total equals value. And then we don't have the value available yet, so we need to take that as an input from the user. So it's going to be one of these that contains a input. We might need to get the input like this one, user input equals input a value, or it might be one of these other ones, user input equals enter a value. So this is the same line, just in two different places in the program. So one of those is going to be before the loop starts, because there's going to be a while loop here. One of those will be before the loop starts, and one will be in the loop. Why don't we just go ahead and put that loop, because we know there's going to be a loop where while the user input is not equal to Q, so Q is our sentinel, how we know when the loop is over, when we don't want to continue to do it over and over. So at that point we know we will need to have a variable called user input that it can either equal Q or not equal to Q. So we're going to need one of these user input equals input before the loop begins. And then if we have user input will be containing the user's input. We still haven't dealt with this initial value up here. So to get that initial value, our options would be to take int of user input. So we'd either need to ask for the user input first and then take int of user input, or we could just do this initial thing, enter a value. It says nothing about the quitting process because we're assuming they need to give us at least one value. So first we'll take the value, maybe put that here for clarity. So count is 1, we have one value, the value is, and then we take a string of that value, so the string form of the number 99, for example. Then we use the int function in that call to turn that 99 string into the 99 number. Then we take that value and we put it as the current total. So we have one value and the total of the sum is just that value. Then the average at the end is going to be the total divided by the count. Before the loop begins, we're going to take the user input and say, when we're taking that, enter a value or Q to quit. So if they enter Q, we're not going to enter the loop ever. If they don't enter Q, they'll have entered a string value that will then need to convert that string number into a number. So an integer function will convert that user input to a number. Then we will, inside that loop, we will update the total by adding the value to it. So total equals total plus value. Value is a new number to add to the total, and count is going to be increased by 1. Count plus equals 1, or count equals count plus 1. Then finally, before the loop swings around, we will again ask for user input, which on the next iteration will then be turned into a value, added to the total, etc. So we've asked for the user input once before the loop begins, and then every time subsequently that we swing around, we'll ask for a new input. If that new input was Q, we'll know to exit the while loop and then calculate the average. And it looks like we made a mistake. Count, oh, we need to do they did specifically tell us you should ensure there's at least one input, so maybe that has to be the very first line. And there we go. So if I wanted 100% here, I would go through it, do this over again, but I think I'm going to just move on. Play with the following activity to learn how to find the largest value in a sequence of inputs. You examine each input in turn, and when you find one that is larger than the largest one that you've seen so far, store it as the largest. When you see the sentinel value, meaning the thing that makes us stop the loop or quit the loop, the letter Q, you have found the largest value. So Q is when we know to stop doing the process that we're repeating over and over. And the process we're doing is look at the next value, decide if it's larger than the current largest. If it is, save it, and then move on to the next one, and so on and so forth. And so this isn't actually a programming task, it's a interactive example. So we're gonna first ask for the next input with this button, and it's 36. So we have no initial value, so 36 is the only value we've seen, so it must be the largest. Now we'll take the next input. 61 is larger than 36. Our current one of 61 is larger than 36, so we will store that as largest. We'll take the next input, and it's 29, but 29 is less than our previous largest, which is 61, so we'll just say next without storing. 84 is larger than 61, so we'll store it. Take the next input. 49 is less than 84, so it's not largest. Skip it. Next input. Another 49. Skip it. Q, and we know we're done. And then we can play it back to see the process that just happened step by step. Store 36. Next input. Store 61. Next input. Don't store 29. Next input. Store 84. Next input, don't store 49. Next input, Q, done. Rearrange the following lines of code to produce a program segment that displays both the maximum and minimum of a sequence of integer inputs. You may assume that at least one integer value will be entered by the user. So again, we're going to take that initial input before beginning. So we know there's an initial, oops, let's click start. An initial value is int input enter a value. So take from inside out, that is, we're asking them enter a value, they give us a string, like the string version of the number 6, for example. Then we convert that to a number with the int function and store that number 6 into the variable value. Now we need to initialize our largest and smallest. Since we've only seen one value, it is both the largest, the smallest, and the current. So largest is value, smallest is value, and then we're going to need a loop, and at the end we're going to need to print the max and the min. So we know at the end we'll print the result, and then somewhere in between here we're going to have some loop. So we'll need while user input is not equal to Q, and we need to get that user input before we can use it. So we'll need to use one of these, user input equals input enter a value Q to quit. We'll need to use one of those before the loop even begins so that we have a condition to evaluate when we start the loop. So did they enter Q before entering even a second value? Then we don't go into the loop at all. If they entered a value that is not Q, then we enter the loop. So now notice we don't have the int part here. Again, so we have to convert that to an int in a second step since we didn't do it in a one-liner. So we'll convert to a number in that line. Then we'll check if that number is greater than our current largest, same as before. Largest equals value. That needs to be indented. And then if value is less than smallest, this is just a different thing we're looking for here. Instead of the larger one, we're looking for a smaller one. So the condition of these if statements, if value is greater than largest versus if value is less than smallest, then we save it. So these won't, neither of these will necessarily execute at the same time. They'll just execute when they're relevant. And then at the end of the loop, we'll need to retake user input because we had the initial one up here, we have the second one down here before the while loop starts, and then we have the last one we need to do so that when it swings around, it has a new input to evaluate whether it's Q or not. And then at the very end, we print. Complete this program. Let me reset. I had recorded this previously and lost the recording. So complete this program that prints the position of the last uppercase letter in a string. Print -1 if the word has no uppercase letters. So -1, they're telling us, is our sentinel value. This is how we know, or no, sorry, this is not our sentinel value. This is our initial value. So we know that if there are no uppercase letters, that edge case of how do I know the last uppercase? What if there are none? If there are none, we return -1. So that's a good sign that that is our initial value for what we're printing. And down here, it looks like we're printing position as -1. Now, there's something wrong with this, but let's just move on and assume that we're saving the current position as position, because this is saying complete the program to print the position of the last uppercase letter in a string. So we're printing it down here, so initially we need to have -1. Now in here, we would need to do while something is true. So while we're moving through the letters in the string, then ch equals word at position, take the word at a current position and get the letter at that current position. Well, oops, we have a problem. So keeping the location of the last uppercase letter in position is now not going to work, because word at -1 is not going to give us the first letter in the word for our first time into this while loop. So actually there's a little bit of a trick in here. That position should not hold the found position, but position should hold our current position. So we're going to go 0, 1, 2, 3, 4, etc. in terms of the letter positions in the word. And then that means down here we can't use position, because position is just going to go 0, 1, 2, 3, 4, etc. up to the length of the word -1. So for a 3-letter word, our indices will go 0, 1, 2, and that 2 would be our final position. Always for a 3-letter word, we're always going to end up at 2. But maybe there's not an uppercase letter at position 2, so printing position is not going to work. So probably we're going to need to print found instead of position. Now found is where we're going to track that position of the last uppercase letter. So initially -1, because we don't know if we found any yet. We're starting at position 0 to start checking. We know when we're done, so our sentinel for the loop is we know we're done looking at letters in the word when we have already looked at the last letter in the word. So we've already looked at it if our current position is less than or equal to len of word -1. Length of word gives us the length of word. So 3-letter word is length 3. -1 gets us to 2, because our positions in a 3-letter word are 0, 1, 2. So if our position is less than or equal to that, then we are okay to continue another iteration. So if we're less than or equal, so equal would be the final one we experience. We're at position 2. We are at length of word -1. It is valid to do our final swing around the loop, but the next time we increase position, then it's invalid. And a simpler way to say this also, the same thing as less than or equal to length -1, that's the same as saying less than len. Same thing. Now we get the character at that position that we're currently at. We check if it is uppercase. If it is uppercase, we will set found to be current position, wiping out the previous found, initially of -1, and then later as other uppercase letters. And then finally we need to do some change to make sure that this while loop doesn't go on forever. So we need to increase that position. We start at 0 position, we go to 1 position, we go to 2 position, and 3 and 4, and so on. So we will need to take position and increment it, which means position plus equals 1, or position equals position plus 1. One more. Walk through the following code that counts how many adjacent duplicates are in a sequence of non-negative integer inputs, using a negative value as the sentinel. Assume the inputs are 1, 2, 2, 4, 4, 4, 3, negative 1. So in this code, we have a counter for the duplicates. We take in a value. While the value is greater than or equal to 0, previous equals value, so we save the last value. Then value equals int input, enter a value, so we take in a new value, but we're holding the other one to the side. If the previous one is the same as the current one, that indicates a duplicate, so we increase duplicates by 1, and then we swing around the while loop. While value is non-negative, then save it, get a new one, compare. What this does is it counts duplicates of all types. So for 2 here, there's one duplicate of 2. But for 4, there are 2 duplicates of 4 because there's 3 4s, the initial one and 2 duplicates. But we're counting all of those. So here we have 1 duplicate of the 2, and then 2 duplicates of the 4, so for a total of 3 duplicates in the entire sequence, because the 2s and the 4s count in the same duplicate count. So we initially have duplicates is 0, we're entering that value. Value is coming in, the user entered 1. While it's non-negative, save it, so we save 1 as previous as well. We take in a new value, which is 2. Is 1 equal to 2? No. So we don't enter this loop, and we go back to the top of the while loop. Now save the previous. Previous becomes 2. New value is 2. Are the previous and the current the same? Yes. So we enter this loop and increase duplicates. Duplicates goes from 0 to 1. While non-negative, which 2 is non-negative, save previous, which was 2. Then new value, now 4. Is 4 the same as 2? No. So we don't increase duplicates. We go to the top of the loop. And then save previous was 4. New value is 4. They are the same, so we increase duplicates. Please enter a new value of duplicates, goes from 1 to 2. Non-negative, save the previous of 4. New value 4. They are the same, we increase. Duplicates goes from 2 to 3. Swing around the while loop, save the previous of 4. New value is 3, not the same, don't increase duplicates. Go back to the top of the while loop. Previous is 3. Value is -1. We know that's our sentinel value, but we're not there yet. Is -1 the same as previous, which was 3? No. So we don't increase duplicates. We go back to the top of the loop. Now value is not greater than or equal to 0. So next line to be executed is not inside the loop again. It's passing over the loop to printing duplicates. So that concludes this assignment.